Hi everyone, welcome to my channel. Okay, so the question that we want to solve today is basically differentiating the square root of x using the first principle. Okay, so how do you differentiate the square root of x using the first principle? It's what we're going to look at today. Okay, so to start with, we need to write the formula for finding the formula for first principle. Okay, so what is the formula? The formula is, so if we're finding f prime of x will equal to f of x plus h minus f of x over h, and there's also the limit. Okay, there's the limit involved. So the limit is basically, so just forgot the limit here. I need to also include the versus the limit. So we have the limit as h approaches 0 of f of x plus h minus f of x, okay, over h. So that's basically how it's supposed to be. So we know that h is approaching 0, okay. So as we are solving, we have an idea that this h that we have here is approaching 0, but it can never be 0 because we cannot divide with 0, okay. We can never divide by 0. Okay, so it's a case we cannot divide by 0. Okay, so how do we use this formula to make sure that we find the derivative of the square root of x? So here's what we're going to do. Okay, we will start solving this one. So the derivative of that, which is f prime of x, so f prime of x will equal to the limit as h approaches 0 of so here we're going to substitute this into this. So here we are going to have x plus h minus the square root of x over h. Okay, so now when we reach this stage, what we will basically do is to try and deal with the numerator here. We're going to multiply the numerator with its conjugate. Okay, so what's the conjugate of the numerator? So we're going to have f of x, f prime of x will equal to the limit as h approaches 0, okay, of x plus h minus the square root of x, okay, multiplying this one with its conjugate, which is just x plus h plus the square root of x, okay, over we're also multiplying the denominator with its conjugate, the conjugate for the numerator, x plus h plus the square root of x. So this is basically what we needed to do. So we are multiplying this with that to make sure that we get rid of the square root that are there, so that it becomes much easy. Okay, so now when you reach here, due to my space here, I'll just try to explain what is happening. So what is happening is you're multiplying this times this, and obviously the square roots will go. You remain with just x plus h. Okay, so this is what you're going to have. So f prime of x will equal to the limit as h approaches 0. Now here, after simplifying here, okay, I'll try to show how we're going to simplify this part in the next video. Okay, let me just try to make a video on how we did simplify that. Okay, I'll make a video explaining how that will actually result into us having something like x, okay, due to my space. So we're going to have x plus h minus x over h multiplied by the square root of, okay, the square root of x plus h plus the square root of x. Okay, this is what you're going to have in the denominator, and that's what you're going to have in the numerator after you multiply the numerator. So here we can see that this x is positive, this one is negative. They easily cancel out, so you remain with h. Okay, so this is if I can use this space here, so we are going to have f prime of x will equal to the limit, okay, the limit as h approaches 0. We'll have h on the numerator. Okay, I don't think this space is going to fit. Let me just wrap the upper part. Okay, I'll use this part here. Okay, I'll use this part. Hopefully it's going to be enough. Okay, so what we're going to have is we're going to have this. So f prime of x will equal to the limit as h approaches 0 of h over h, then the square root of x plus h plus the square root of x. Okay, but we can see from afar that we have h that is being multiplied to these two quantities, which is the h here and the h up. We can easily cancel that out. So this h and that h, we can cancel them out. And what we are going to have here, we're going to have the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. So once you have that now, that's where now the limit comes in. Okay, so the limits are telling us to say h is approaching what? Is approaching 0. So if h is approaching 0, that means that this h here will be 0. Okay, so this h will be 0. So if we want to use the limit there, what will happen is this is going to be 0 and the final answer will be 1. And then here we're going to remain with the square root of x plus the square root of x, which is the other part here. So adding, because these are the same things, we can easily add them. They are like terms. So we're going to have 1 over 2 the square root of x. So that is the final answer for you. Okay. So if you try to differentiate the square root of x using the first principle, whichever method you are going to use, you need to find this answer. Okay. Thank you very much for watching, and follow for more, as we are going to be making these videos so interesting, such that you should be able to learn 1 or 2 things.